In this video, we are going to look at simplifying compound fractions. I do want to note before we get started that in some textbooks these are referred to as complex fractions. So when you hear compound fractions and complex fractions, you can think of those as interchangeable names for these types of fractions. So with that, let's talk about what is a complex fraction or a compound fraction. Let's say I have 5/12 over 3/8. This is what we mean by a compound fraction, basically fractions within fractions. And we're going to be looking at these with varying levels of complexity. But the important thing to note is that, remember, fraction bars mean division. And so basically when we have fractions inside of fractions like this, we are essentially dividing them. So this is the same thing as if I had 5/12 and I divided that by 3/8. We've already looked at division. So essentially with compound fractions, we are presenting division in a different way. There are some further complexities with these that we will discuss in a bit, but it is important to note that the division bars coincide with, the fraction bars are the same as writing out a division symbol. As a matter of fact, you can think of a division symbol as a fraction bar where the numerator and the denominator are just dots instead of values. Now, before we dive into actually simplifying compound fractions, I want to contrast a couple different configurations that we will see when working with compound fractions. Okay, here I've written out a couple of these monsters, and the way we need to approach these two compound fractions is very different, and so it's important that you can look at them and see the essential difference here that calls for different methods. So if you look at the first one, the numerator of the first one is all one big fraction. It's all kept within one fraction bar, and its denominator is also one big fraction. So what that means is we can, from the beginning, apply the division of the major fraction bar and essentially take the numerator times the reciprocal of the denominator. We can do that from the beginning. However, if we look at the second monster over to the right, it's a little bit more complicated. The numerator is not one big fraction. Instead, it is two fractions being added. And similarly with the denominator, it is two fractions being added. They do not have one single fraction bar holding them together. That means a couple things for us. First of all, we cannot apply the division of the major fraction bar from the beginning. We cannot just flip the individual fractions of the denominator and multiply by their reciprocal. Since they are terms, they cannot interact with the multiplication and division. We have to resolve the addition first. In other words, we need to go ahead and add the fractions in the numerator and in the same time add the fractions in the denominator. Once we add those fractions, then we will end up with a configuration similar to the monster on the left here. Once we have them expressed as a single fraction, no matter how messy, but as a single fraction in the numerator and a single fraction in the denominator, then we can multiply by the reciprocal. So what I'm going to do is clear this out, and we will work both of these, but it's very important to keep track of what it is about their initial configuration that allows me to proceed the way I will. Okay, example 1, perform the indicated operation and simplify, and then we have the same compound fraction that I had up here before. Now our indicated operation is this division. So essentially we're going to multiply by the reciprocal. And if it helps you to write the numerator with and then divide it by using this symbol, the denominator, then you can go ahead and do that. So what I mean is if you want to write that out horizontally, you're welcome to. I usually leave that step out. and I just go straight to multiplying by the reciprocal of the denominator. So here we have the numerator written exactly as it was, and we change the division to multiplication, and then we have the reciprocal of the denominator. And now we'll just work it out as a multiplication problem. As we've seen when we work the other multiplication problems, we need to factor anything that can factor, and then cancel the factors that are similar from top to bottom. Nothing in the first fraction factors, so I will just copy that down. In the second fraction, the numerator has a GCF of 4. So when I factor that, I get 4 times the quantity 2a minus 3. And then I can just copy down my denominator because it's already just as in factor 4. So now we're going to reduce anything in the numerator that will reduce with the denominator. So I have a couple a squareds up here. This is going to reduce down to a single a and cancel off this a down here in the denominator. And then I have the full factor 2a minus 3 that I can cancel with this 2a minus 3. And so that leaves me with 4a in the numerator. And then everything in the denominator canceled, so that's going to be a 1, but then that will divide down to just a 4a. And there we have it. So now that we have that one down, we're going to turn to that one I had written on there earlier that was on the right-hand side. It's a slightly more complicated example. Okay, so here's that example written out. And again, what we talked about earlier is we have two separate fractions in the numerator, so we need to start by adding those together to get them down to one fraction. Same thing with the denominator. We have two separate fractions, so we need to add them to get them down to one fraction in the denominator. And once there is a single fraction in the numerator and a single fraction in the denominator, that's when we can turn to evaluating the division, in other words, multiplying by the reciprocal. So essentially with these problems that are in this configuration, we're going to be doing all of the operations that we've learned so far. We will be adding in the numerator and denominator, and then we'll be dividing, which becomes multiplication, and then of course after doing anything at the end you want to fully simplify. So that covers everything we've done with these rational fractions so far, or rational expressions. So these are good summation problems of a sort. So then to add the numerator, we need to come up with the LCD in the numerator, which is going to be a 2y. And then to add in the denominator, we need to come up with the LCD in the denominator, and it's going to be a 3y. Once we decide what our LCD is, we need to get a common denominator in each one of those. So remember, to get a common denominator, we multiply through by what's missing. So with my first fraction in the numerator, the part of the LCD that it's missing is the 2. So I'm going to multiply top and bottom of this fraction by a 2. And then moving on to the second fraction in the numerator, the part of the LCD that it's missing is the y. So I will multiply top and bottom of this fraction by the y. Now that I have those missing parts written in, I'm going to turn to the denominator. In the denominator, the first fraction in the denominator is missing the y of the LCD. Now we're looking at the LCD of the denominator now. So I will multiply in the missing y, top and bottom for the first fraction in the denominator. Looking at the second fraction in the denominator, it's missing the 3. So I will multiply top and bottom by the 3. So now I have all the pieces that are missing written in, and now I'll just go through and do the computations. So starting with the top, the first fraction in the numerator will simplify to a 4 over 2y. Now I'm just putting the 2 in front of the y because that's the normal way of writing it. And then the second fraction will become a y squared over 2y. Now moving to the denominator, the first fraction in the denominator will become a y squared over 3y. And the second fraction in the denominator will become a 9 over 3y. So now the fractions in the numerator have the same denominator, and separately the fractions in the denominator have the same denominator. Now that their denominators are the same, we can go ahead and do the math across the numerators and write them over one common denominator. I'm going to write my result, kind of swinging back around to the left. Doing the addition in the numerator would give me 4 plus y squared divided by 2y. The 4 and the y squared aren't like terms, so I just put them together over one common denominator. The fraction in the denominator then combines and becomes y squared plus 9 over 3y. Now after all that work, we are essentially back to where we started with example 1. We have one fraction in the numerator and we have one fraction in the denominator. Now that we've gotten to this point, we can apply the division of the major fraction bar and multiply by the reciprocal of the denominator. Doing that gives me the 4 plus y squared over 2y, that's my numerator of my compound fraction, times 3y over y squared plus 9, that's the reciprocal of my denominator. Now that I have it switched to multiplication, our goal with multiplication is to factor anything that factors and then cancel common factors. This numerator does not factor. It looks like it's kind of tricking us. This denominator doesn't factor. Again, they're kind of tricky because they look like difference of squares, but they're sum of squares, and sum of squares does not factor. So we have to leave those as is. And then the 2y and the 3y are already expressed in factored form. So all we can cancel off in all of this are the y's here, because those are y's that are factors. Also, just for the sake of emphasizing it, because it's always tempting, we can't cancel this y squared with this y squared, because those y squareds are terms in their respective numerator and denominator. But the y's we can cancel are being multiplied by the 2 and the 3, so those are factors and we can cancel those. So cleaning this up gives me 3 times the quantity 4 plus 2y in the numerator, and I just brought the 3 out front because that's the normal way of doing things. And then in the denominator we have 2 times the quantity y squared plus 9. And that's as pretty as that is going to get. Some people might want to rewrite this piece here, this factor, in descending order. And if you want to, that would be fine. There would be nothing wrong with that. I just don't find it highly necessary. Okay, we will do one more example with these to make sure you're seeing where all the pieces and parts are coming from and going to. Alright, so we have 2 over w plus 1 plus 3. All of that over 3 over w plus 1 plus 4. Now, again, it's good to take a second before you just start doing things to consider what type of compound fraction we have. Here, this is a fraction. Now, this isn't technically a fraction, but it is a separate term. So before, and same thing in the denominator, we have separate terms. So before we can multiply by the reciprocal, we need to combine these down so we have one fraction in the numerator, one fraction in the denominator, and then we can multiply by the reciprocal. And as we've talked about, when we're dealing with non-fraction numbers or integers, we can think of those as over 1 to put them in fraction land. And so doing that, we can see that the LCD of the numerator is w plus 1, and the LCD of the denominator is w plus 1. So then we'll go ahead and rewrite the fractions so they have those denominators. Our first fraction already has that denominator, so we'll just copy it over. But our second fraction, the 3, needs the full w plus 1. So we need to multiply by w plus 1 over w plus 1. Remember, when multiplying by a factor with multiple terms, it's necessary to wrap that in parentheses. We also need to multiply the 4 in the denominator by our w plus 1 over w plus 1. Okay, now that I have all of the necessary pieces multiplied in, I'll go ahead and work on simplifying these fractions. So we're going to do the math across the numerators and write these over one common denominator. So in the numerator, I'll have a w plus 1 denominator, and then for that, we're going to do the math across the numerators here. And as I copy these over, I'm also going to distribute the 3 into that w plus 1. This gives me 2 plus 3w plus 3. Take a second and make sure you see where all that came from, and then we'll do the denominator. In the denominator, I'll have 1w plus 1 for my denominator of my denominator. And then I'm going to do the math across the numerator that's in the denominator. And just like with in the numerator, I'm going to distribute this 4 as I go. This is going to give me 3 plus 4w plus 4 in the numerator of the denominator. And now they are all as one fraction in the numerator, and it's all as one fraction in the denominator. So at this point, I could multiply by the reciprocal. But I want to go ahead and simplify or combine like terms in my numerator of my numerator and my numerator of my denominator first, because it'll just be easier to progress if that were already simplified. Doing this gives me 3w plus 5 over w plus 1, all of that over 4w plus 7 over w plus 1. Now seems like a great time to multiply by the reciprocal. When we do that, we have 3w plus 5 over w plus 1 times w plus 1 over 4w plus 7. Now once we have this, we would want to, we're now in multiplication phase, so we would factor anything that can factor. It turns out that none of these actually factor. So we can't factor anything, so we're going to cancel any factors that are completely the same. And since nothing really factored, we're thinking of our multiple terms all as one group as one factor. So we're not canceling any individual terms, but the full groupings are being multiplied by each other, and so they are factors. What this means is I can cancel my w plus 1s because they're identical factors, and that's as pretty as this is going to get. So our final result is 3w plus 5 over 4w plus 7. Go ahead and give some of these a try and see how you feel. Be patient with yourself during the process.